So far we have not talked anything about stats, we have talked about population, sample. The stats comes when you are talking about inferring from the sample. So the key questions which we will talk about are stats are how should I collect the data itself, okay, so that bias everything is avoided, describe and summarize the data that I have collected, okay, this is still not inference, just describing what you have done. Then finally what does my data tell me about the way the world works, that is inference. This is where you talk about the averages values, mean, variance, correlation, etc. Here you talk about design of experiments, okay, shortly called DOE, design of experiments, where you want to avoid confounding, like if there is a previous condition, a known condition, you do not want to take them in the study, right. If somebody is having diabetes, you do not have them in the study where the drug is known to influence the diabetic patient negatively or positively, right. So factors, confounding factors which will prevent you from inferring, you have to avoid it, but it is not always possible, confounding will be there. So that is where we will learn about what I call it as factorial experiments, okay, multiple factors, multi-factor experiments, like dose levels is one example. So we will talk about multi-factor experiments. How to describe and summarize data, this is where graphs, we will talk about plots, we will talk about summary statistics. And the third important question, when we talk about inference, we will use not only this, we generally call it as hypothesis testing. Analysis of variance, ANOVA, called analysis of variance, and then we will start worrying about ANOVA, multi-factor ANOVA and its variance. Then we will talk about modeling, regression, etc. Okay. So these are the three important questions we will start addressing in this course, okay. Okay. So I have given an example like evaluation of penicillin, treatment A versus penicillin and some other drug chlorophenicol, treatment B for bacterial pneumonia in children less than 2 years. See how now we have the objective, I want to evaluate just use of penicillin or penicillin and another drug for pneumonia less than 2 years. So my population is clear. What is my population? 2 years, just less than 2 years, 2 years with bacterial pneumonia, okay, make it very clear, okay, 2 years, no, you do not administer this drug for normal kids, right, you administer for kids with, so my target population is very clear, less than 2 years with bacterial pneumonia, that is my study. So what this statement implies is very important, you cannot recruit any less than 2 year kid for this study. The study should involve kids who have already bacterial pneumonia, okay. That is the key, because that is where I said your simple statement saying that do not use it other than the intended purpose, specific purpose, that clearly states it is not for common audience. If you misuse it, you are misusing it, okay. So the clarity should be there, it is less than 2 years with pneumonia, bacterial pneumonia. Now what are the questions? What is the sample size needed to demonstrate the significance of one group against another? Now we are making 2 groups, okay. Now there is, do I do a placebo or no? You all know what is a placebo, right? Do I do a placebo? No, I am comparing group A versus group B, there is no placebo here, group A versus group B. How much better? How do I quantify which one is better, okay. What is normal variation in clinical measurement? So is it mild? So bacterial pneumonia itself will have grades, not have, so kid with the bacterial pneumonia starting stage mild. So bacterial infection, right, the level of infection is important, right, whether so if you look at, that is what I said, right, I do not know. So if you look at this antiretroviral drugs, ARVs, which are actually lifesavers for many today, there is not just dosage, there are several, a suite, it has about 10 to 15 ARVs are there, first layer, second level, third level drug. Why? First level is for certain purposes, that is the first thing. If it is not coming under control, then you give second level. Now, what is the difference between first level and second level? First level drugs may have lesser side effects, second level may have more side effects, and third level have even worse, right. So that is why it is very in at least not like, unlike what do you do in data science, throw a neural network for everything, which is the worst one can do, but nothing will happen here, whereas you cannot throw a 1000 mg medicine or a very high end antibiotic for every person. Result, what will happen? Drug resistant bacteria. Today there is a big issue of drug resistant bacteria because of misuse of antibiotics, right. So what is normal? So you have to have the gradation in infection as well, not just in dosage, gradation in infection. So those are all factors, these are all factors. How reliable and valid is the measurement? Now your parameters, whatever you say, some of them could be objective, some of them could be subjective, right. You cannot always do objective alone, some of them the doctor may give you based on his opinion, fine. ECG, what will you look at? PQRS, PQRS, simply PQRS, what is it? Time duration between PQRS, is that all? Amplitude. So if I give you an ECG, you will say this is what it is, and this I can only automate, the machine only will give you, that is all, right, the machine will give you or not, huh? So what is the doctor doing there? So doctor does not want a ECG, so you cannot get any information from ECG from a doctor compared to this time durations. See, you know the time duration, you know average duration between PQRS, this should be this because your heart rate activity is known, right. So you give the PQRS wave signal to I am working with the surgeon Zimmer, head of the department, we work with Zimmer guy, you give him cardiac department to give the cardiac department, you think that is all they will be able to tell? Just look at the PQ, hey PQRS, this is the time durations, is that what they are going to say? Huh? Yes, so they look at all the 12 leads, right, this can be done using 3 leads. A heart attack can be occurrence of heart attack or whether heart attack occurred or not can be predicted using ECG, can be looked at using just ECG. The amount of blood flow to the heart can also be observed using ECG, okay. And I recently one of my friend's wife, I have to send a ECG to our doctor, he looked at and rushed to the hospital, an angio is required, blood levels to the heart are lower. I also looked at the same ECG. For me I was looking at, as you said, PQRS peaks and time duration, I know that is not sufficient, thankfully I know that it is not sufficient, so I have to pass it on, right. So these are qualitative, not everything can be quantitative. So you have to worry about, especially in clinical domain, getting to infer the doctor's thought process, right, quantifying the doctor's thought process, right, that is very difficult. So clinical measurements, radiological measurements and inferences by the doctor, how do I put it, okay. Technical errors, that is always there. How does one interpret abnormal values? Is it an outlier, is it something to do with the sample, etc. So these are some of the questions, a simple case we will have. So if you look at it, what are the areas which we look, clinical medicine, preventive medicine, and what do we cover as a statistician, biostatistician, what can you help? You can help in design of the study, sample size and power calculations. What is power calculation here? Any idea? Power. So let us say if I go to, so you all know the in Indian penal, according to the judges, and if you would have looked at in movies, what is the statement a judge will make in a movie? One, you can let go of 100 guys who are, or n number of guys who are criminals or convicts, truly convicts, but you cannot punish a innocent fellow. What does it mean? That is actually a profound statement. What does it mean? So there are two kinds of errors you make in even a judge when he gives a statement. That is why I said null and alternate hypothesis. If you look at my statement, I have clearly written with evidence you disprove null hypothesis, or there is not enough evidence to disprove null hypothesis. You never say one is correct over the other. Very interesting, right? You never say null hypothesis is correct because I do not know what is truth. You never say alternate hypothesis is also correct. So statistics, that is where a game is, that is where lies can be made easily. You have to be very clear of statement what you make. You never say which is right, you only say with evidence I cannot disprove this, I have evidence to disprove. So if you take a judgment, it will be very interesting. The judgment will say that with evidence, because of evidence, okay, they will not say this is this evidences suggest that he is a convict. They will not declare he is a convict. I believe, no statement is made like that. I believe, I does not come into picture. Evidence suggests this, or there is not enough evidence to prove that he is guilty. There is enough evidence to prove him guilty. Nobody knows he is guilty or not, and nobody cares also. Ground truth who will know? Only that person can know, right? And of course you assume that that particular person is not going to tell the truth, okay. So you cannot lie on his or know whatever he says. So you simply say whether evidence is enough, evidence is there or not. So if you want to, what are the errors you make? What are the type of errors you will make then? One case, true maybe he is a convict, he is a criminal, he might have committed the crime, but what is the error you will make? There is not enough evidence to prove that he has committed the crime. That is one kind of error. And there is another kind of error where we say he is not guilty, but evidence is such a way that he is guilty. This is another kind of error. So there are two kinds of errors. We will call it as type 1 and type 2 error later on. So there are two kinds of errors you are going to make. And what is a power? Means is when he is guilty, what should the judgment be? When he is guilty, what should the judgment be? Judgment should be that he is guilty. And what is the null hypothesis in this case? What do you start with? What do you start with? When somebody is taken to the court, what do you start with? Huh? You treat him as accused. He is innocent, he is not guilty unless proven otherwise. So you have to make these statements very clear. When you look at these is statistics, this is hypothesis. Everywhere around you will see this kind of statements made, okay. He is not guilty and unless proven otherwise. So that is my null hypothesis. You have to try hard to prove that he is guilty with enough evidence. If there is lack of evidence, he may be sent out. If there is enough evidence, he may be sent inside, okay. So now that is where two kinds of errors. So power of test is something where when we say power, we say that what is the correct, if it is, so what do you want ideally? Ideally what do you want? If he is a criminal, you have to say that he is a criminal, the evidence should suggest that he is a criminal. So that is called a power of a test. A test is saying that a power is high means if it is most likely that if he is a convict, he will be sent to jail or given sentence, right. So that power calculation, so design of study, sample size, power calculation, selection of sample and controls, questionnaire designing, okay, management, descriptive statistics, how do you present the results, okay, application of univariate and multivariate statistical analysis techniques. This is what you can do as a biostatistician. This is the role of a biostatistician.